Now, after we've detected and identified the species, we need to count them. In the natural setting, animals don't come in conveniently sequenced. Most species don't. They appear together as a bunch, as a crowd. So we need to count crowds. The Antarctic ecosystem is in serious risk. Researchers have been trying to study the impact on penguins which are at the top of the food chain. So these are challenges due to climate change and other human interventions. So they needed the help of technology to collect the data, because though there was intuition that something was going wrong, they didn't have the data. So how do we use technology to save the penguins? So not just this guy, but the entire bunch. So Penguin Watch is an initiative by Oxford University. About 10 years back, they set up camera traps in Antarctica. They set up these 100 camera traps in several locations, and they started capturing time-lapse pictures every hour. So across 10 years, we have rich footage and millions of pictures available. But the challenge is you need to label the pictures first so that the model can start identifying the penguins. It's a massive task. So to solve that, there was a crowdsourced labeling initiative which was launched. On the Penguin Watch website, they called for volunteers to come from across the world to identify the penguins by placing markers. This is how it works. Once you get into the website, there's a quick tutorial which says that you will have to place markers on the penguins, the adults and the chicks. In case you're not able to identify any penguins or the image is hazy, skip them. If you can identify animals, other animals or humans, mark them with a separate marker. So once you go about this, you can quickly place markers on each image, submit, and you get done. And thanks to this effort, hundreds of thousands of images have been neatly labeled and were readily available for training the AI model. So now that we have the data and we have it labeled, the next stage is choosing the model approach. While deep learning model is the go-to choice here as well, what we have seen so far are models which use bounding boxes. They are good to identify those images where you have these entities clearly visible. Say you have a head which is visible, but it doesn't work quite well for counting crowds. Why? There are people at the front who naturally hide those at the back, the problem of occlusion. And there are different portions in the picture where the density is different. So some portions you can count them manually, in some portions they are closely huddled together. And there's this perspective distortion. Faces in the front look much bigger compared to those at the back. And camera angle could be a killer. Whatever is a frontal shot looks very different from a top-down one. So that's where density estimates are pretty useful. So there are deep learning models which use density approximations. They split the image into different portions and identify the density in each section. And then the counts are localized and added together for the entire image. So this way, we are able to handle all of these challenges we have seen, and we are no longer looking for heads in the image. And what works with crowds of people we found was equally effective with counting penguins, crowds of penguins. So we used a cascaded CNN as a model, and it had two stages. Firstly, the image is split into a 3x3 grid. So you have 9 patches, and each patch passes through these two stages. Stage 1 is a high-level crude approximation done by the model. And then the model passes to the second stage where it does the density approximation, comes up with a more accurate estimate for that patch. And then all of these are added together to come up with a total count. And this count has been found to be pretty close to actual numbers. When we ran it on penguin populations, these are the results. So you can see a low density image at the top where there are 5 penguins and the model is able to count them. The second one has 46. The model gets an exact count in this case, but the mean absolute error for us was about close to 10, which was pretty good and close to published papers. So now researchers have a way to identify the change in penguin populations over the decade.